Hi there. For this video, we'll be discussing about the two-point form of a line. So recall that in the previous video, we learned how to obtain the equation of the line using a point and a slope. This time, what if we are only given 2 points? So, take note that given 2 points, the equation of the line is y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. So the equation of the line can be written in this form. This out here is called the 2-point form. So we'll try to derive how we arrived in this formula. So in here, we are given an illustration of a graph of a line involving 2 points. And this is the formula that we want to obtain. Now the derivation for this is quite easy. So let's move this first. First, we note that by the point-slope form, we note that the equation of the line can be written as y minus y sub 1 equals m times x minus x sub 1, wherein m out here is the slope. Given 2 points, we know that the slope of the line is given by the change in y over the change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we can plug this in to the point-slope form. Doing that gives us y minus y sub 1 equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 times x minus x sub 1. And there, we had arrived with our desired outcome. Now let's try to apply this formula in some examples. So given the point 1, negative 1 and 2, 4, find the equation of line in slope-intercept form. Now, feel free to pause the video so you can try this example on your own. Let's start. So in here, we are tasked to find the slope-intercept form. But unfortunately, the slope is not given and the y-intercept is also not given. So we can't immediately get the slope-intercept form. But fortunately, we are given 2 points out here. So we can use the 2-point form. So note from above, the 2-point form is given by y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. So to apply this formula, we first set what our x sub 1, x sub 2, y sub 1, and y sub 2 will be. So we can set this first point to be x sub 1, comma y sub 1, and the second point to be x sub 2, comma y sub 2. Now, we simply plug in the given values. So we'll have here y minus y sub 1 out here, negative 1 equals y sub 2 is 4 minus negative 1 all over x sub 2 is 2 minus 1 times x minus 1. And we just simplify this one. So on the left, we'll have here y plus 1. And for this out here, we have 4 minus negative 1 will give us 5 over 2 minus 1 is 1 times x minus 1. From here, we'll have, just removing the denominator, we'll obtain y plus 1 equals 5 times x minus 1. Since our goal is the slope-intercept form, so take note that the slope-intercept form is given by this form. So we know that y out here should be isolated on the left. So to do that, we move 1 to the right. So that will give us y equals 5 times x minus 1 minus 1. Then we just distribute 5 out here to obtain y equals 5x minus 5 minus 1. Simplifying this further, we'll have 5x minus negative 5 minus 1 will give us negative 6. And this out here is actually our slope-intercept form. If you want it to be clearer, we can write it as y equals 5x plus negative 6. So our slope is 5 and our intercept is negative 6. Sorry about that. Let us move on to the second and final exam. So in here, we are given the graph, and our goal is to find the equation of the line in, this time, the standard form. So take note that the standard form is given by ax plus by equals c, wherein a, b, and c are integers, with a being positive. So in here, since we are given again 2 points, we can take advantage of the 2-point form. So again, note first that the 2-point form is given by y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. So before we can apply this, we first set what our x's and y's will be. So for this one, we can set this as x sub 1, y sub 1, and this will be x sub 2 and y sub 2. So be careful not to interchange the values of x and y out here, as that will give us an incorrect outcome. Oops. Let's now try to find the equation of the line in standard form. So plugging in, we'll have here y minus y sub 1 is 1 equals y sub 2 is negative 3 minus y sub 1 is 1 all over x sub 2 is 1 minus negative 2 times x minus negative 2. So we just plug in the values. Simplifying this, we'll obtain y minus 1 equals negative 3 minus 1 will give us negative 4, and in the denominator we'll have 1 minus negative 2 is 3 times x plus 2. Since we don't want any integers in the standard form, what we can do is we can multiply this out here by 3. So let's clear out this 2. By doing that, we obtain 3 times y minus 1 on the left, and on the right, 3 out here would cancel. So we'll have here negative 4 times x plus 2. Distributing 3 and negative 4 to the expression inside will give us 3y minus 3 equals negative 4x minus 8. And now we are almost done. Simply move negative 4x to the left and this negative 3 to the right to obtain 4x plus 3y equals negative 8 plus 3 will give us negative 5. And this out here is the equation of the line in standard form. So as you can see, by obtaining the 2-point form, we can easily convert this to either the slope-intercept form or the standard. So with just 2 points, we obtain the equation of the line. There. So before I end this, here is an exercise that you can work on. So in here, our goal is to find the x-intercept of a line passing through these 2 points out here. So the idea here is the same. We first apply the 2-point form, given this 2. And after applying this 2-point form, we take note that to get the x-intercept, what we do is we simply let y be equal to 0. So this is like an application of what we learned today along with a previous topic on coordinate geometry, which is the topic on intercepts. So that's it. I hope you enjoyed this one. Feel free to comment down below any comments, suggestions, and recommendations that you have for our future videos in this channel. Moreover, you may comment down below if you have a solution and answer to this exercise. I'll be happy to check if you got it correct or not. So that's it, and that is all for this video.